Hello, welcome to Tennessee's at Home Learning Series for Math. Today's lesson is for all third grade out there, though all children are welcome to tune in. This lesson is number 7 in a series. My name is Lisa Sharkley, and I'm a third grade teacher at Venus Stewart Elementary in Gallatin, Tennessee. I'm excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see the previous lesson, you can find it on Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson if you hadn't seen any of the others, but it might be more fun if you go back and watch our other lessons, since we'll be talking about things we learned previously. Today we're learning about finding equivalent fractions. Can you say equivalent fractions? Yes. Before we get started, to participate fully, you'll need paper and pencil. Okay? Let's get started. I'm going to start with vocabulary. Vocabulary. Find the equivalent fraction key vocabulary. Fraction. A number that names equal parts of a whole. A fraction names a point on the number line. Denominator, the number below the line in a fraction that tells the number of equal parts of a whole. Next, my numerator, the number above the line in a fraction that tells the number of equal parts that are being described. And our last vocabulary word, equivalent fractions. Two or more different fractions that name the same part of a whole or the same part on a number line. These are our vocabularies, and we might refer back to them. Today, we are going to think about equivalent fractions. A fraction is a number that names equal parts of a whole. We will also think about how to model our thinking about fractions by using area models and number lines. We're going to have to do that thinking that's so important. Let's start off by looking at these two fractions. How are these fractions the same and different? I see this one says 1/2 and this one says 2/4. I know they're the same because both of them are fractions and they both have a numerator and a denominator. A numerator and a denominator. Okay. Now, how are these fractions different? Well, they're different because our numerators are different on both of them, and so are the denominators. Two different fractions can name the same part of a whole. How can we write two different fractions for a rectangular area model? Let's draw a picture to help us think about these fractions. Draw along with me. So I'm going to draw a rectangular area model. Let me shade it in just a little bit. Okay. So this rectangular area model shows what? Okay. And I bet you said 1/2. Two equal parts, one part shaded. Now, if I add a horizontal line, let's see what my area model would show then. Just one, I cut it right across. Now I still have the same area model. I only added a line to make more pieces, to make more equal pieces. Now let's see what my denominator will be. That's my down number. It tells me how many pieces in all. 1, 2, 3, 4. Now I have 4. How many pieces are shaded now? 2. I just found the equivalent fraction. 1/2 is equivalent to 2/4. This is what this area model showed me. Let's look at these fractions. How are these fractions the same and different? All right, I have 1/3 and 2/6. Again, I'm thinking they're the same because they're both fractions. They have a numerator and a denominator, a numerator and a denominator. Now, how are they different? Our numerators are different, and so are the denominators. Two different fractions can name the same part of a whole. How can we write two different fractions for a rectangular model? Let's draw a picture to help us think about these fractions. Draw along with me. Doing the same thing, we just practiced. So this time I'll make my area model a little bit bigger. It's going to have more pieces to it, I think. And what did I cut it into? Tell me. And I bet you said thirds. Thirds. And I'm going to shade one piece. So now I have 1/3. Now, what if I draw one horizontal line like I did just a couple minutes ago? I'm going to draw my one horizontal line. It's still the same amount. I still have my same area model. I just sliced it or cut it. Let's see what new fraction we can come up with now. I'm going to count my equal pieces. 1, 2, 3, 4, 5, 6. Oh, my denominator is 6 now. How many are shaded? That's going to be my numerator. 1, 2. So I just discovered 1/3 is equivalent to 2/6. And my area model helped me. Don't forget, two fractions are equivalent if they name the same part of a whole. And with that model, it named the same part of the whole. The whole did not change. Let's look at a word problem. Let's use what we just discovered to try and solve a problem about equivalent fractions. Listen and follow along as I think and work out this problem. Okay, let's see. Austin eats 2/8 of an orange. Andrew's orange is the same size. He eats 1/4 of it. Show that the two boys eat the same amount of an orange. Okay, so this story problem is speaking of oranges. When I think of an orange, I think of a circle. So I'm going to start off by drawing two circles. My first circle and my second circle. And I try to make them the same size, as close as I could. And make sure when you're drawing models, you try to make them the same size because we're going to be comparing them. So it helps to make them the same size. Okay, this is going to be Austin's. And his is cut into 8s. He eats 2/8 of an orange. So let's make it 1/2, 1/4. I have 8 pieces. He eats 2 of them. 1, 2. Okay, I know about Austin. Now Andrew's orange is the same size. This will be Andrew's. He eats 1/4 of his orange. So what do I need to draw this circle into? And I bet you said 4ths. 4 equal pieces. I drew it into 4ths and he eats 1 piece. Show that the boys eat the same amount of an orange. Let's look at this one. Oh, when I see, let me make sure. When I do it like that, and I do this, I can tell they ate the same amount. I'm going to write a fraction underneath to show that. 2/8 is equal to, oh, let me step over, 1/4. I just wrote an equivalent fraction. I used the models to help me. Let's go to our next problem. We can also use a number line to model the problem about the oranges. Let's try this together. How many parts should we divide the number line into? Oh, let me go back. Now, Austin eats 2/8 of an orange, and Andrew eats 1/4. So, I need my number line to show 8s and 4s. So, I need 8 equal spaces for the 8s. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. I was able to count 8 equal pieces on my number line. So if I had to make a number line, I would do the exact same thing. I would draw my line and make 8 equal pieces. I'm going to label the pieces. Now this would be 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8, which is the same as 1/2. Now I've modeled for my 8s. I've labeled the number line. Now let's do the 4s. So I need 4 equal pieces. Let's see if I can use the same number line. Let's see, what if I do this? 1, 2, 3, 4. I have 4 equal pieces now. And let's label them 4s. And I'm going to leave my loops. 0/4, 1/4, 2/4, 3/4, and 4/4. 4/4 is the same as 1/2. Now, let's see if I can find some equivalent fractions with looking at this. I'm looking at my number line and seeing, do any of them equal? This goes back to the story with Austin and Andrew. Andrew had 1/4, Austin had 2/8. They're the same distance on the number line from the 0, which shows their equivalent fractions. Why is it helpful to use one number line for both fractions instead of 2 separate number lines? Why is that helpful? Do your thinking. It shows or ensures the wholes are the same size, and it's also the same location from the 0 on the number line. That's why using 1 is helpful. Let's review. To show fractions are equivalent, we can show the same amount in equal size models, or we can see if they are at the same point on a number line. As we compare and connect these different representations, we can visually identify how they are related. just a couple more problems for us to practice together. Listen and follow along as I think and work out this problem. Savannah and Ivy, and feel free to read along with me, okay? Savannah and Ivy each order a small pizza. They eat the same amount. Savannah eats 3/4 of her pizza. Ivy's pizza is divided into 8 slices. How many slices of pizza did Ivy eat? Okay, again, we're comparing Savannah and Ivy's pizza. Now I want to draw a model to go with this. I think a model would work. Since we're talking about pizza, I think circles would work perfectly. I'm going to try to draw them the same size, but Miss Sharkley is no artist. I think I got them pretty close. All right. With Savannah's pizza, she eats 3/4 of her pizza. So 3/4. I need to divide it into 4 equal pieces. Ooh, that was pretty good. How many should I shade in if she eats 3/4 of it? And I agree, 3. 1 piece, 2, which would make it 2/4, 3, which would make it 3/4. She ate 3/4. This would be Savannah. Now, Ivy's pizza is divided into 8 slices. All right, I need to make it into 8s. I'm going to do half. Now, 1/4. All right, let's do one diagonal line and one more diagonal line. Now I have 8s. Now I want them to eat the same amount. So how many of the 8s should I fill in? Do your thinking time. So and I'm going to compare it to this one. Oh, I need to fill in this one. Definitely. Oh, this one. Yes, this one. So I'm up to 3/8 so far. This one. 4/8. Oh, I can see 4/8 is equal to 1/2. Let's keep going. This one. 5/8. Seems like I need one more piece to make it the same. Equal amounts. This one. So let's see what our equivalent fractions would be. And this was Ivy. Savannah's 3/4 is equal to Ivy's 1, 2, 3, 4, 5, 6. Numerator is 6. How many pieces in all would be my denominator? 1, 2, 3, 4, 5, 6, 7, 8. 3/4 is equal to 6/8. So how many slices of pizza did Ivy eat? And my answer would be 6. She ate 6 of them. We can also draw a number line to model this problem. Let's try this together. Draw a number line with me like this. This goes to the Savannah and Ivy pizza. We used models. Now I want us to practice with a number line. I'll read it again. Feel free to read with me. Savannah and Ivy each order a small pizza. They eat the same amount. Savannah eats 3/4 of her pizza. Ivy's pizza is divided into 8 slices. How many slices of pizza did Ivy eat? How many parts should we divide our number line into? Well, I know I have to divide it into 4ths and also into 8ths. Okay, let's check and see if it's divided into 8ths first. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 equal pieces. This is divided into 8s. So I'd say 0, 8, 1, 8, 2, 8, 3, 8, 4, 8, 5, 8, 6, 8, 7, 8, 8, 8. We have made our number line into 8s. Let's do the same with the 4s. 4s. Oh, I could put this. I could do this. Let's see. 4 equal pieces. 1, 2, 3, 4. 4 equal pieces. Now I'll number this one 4s. 0 fourth, 1 fourth, 2 fourth, 3 fourth, and 4 fourth. So if Ivy eats 3 fourths, how many slices did, or Savannah eats 3 fourths, how many slices did Ivy eat? I'm finding them on the number line, and it would be 6/8. She ate 6 slices. Another way to show the same problem. Now, you're going to try a problem on your own. Remember to draw a picture or use a number line. Listen as I read it aloud. And please read it with me. Brock eats 1/2 of a candy bar. Michael's candy bar is the same size. He eats 4/8 of it. Show that the 2 boys eat the same amount of a candy bar. So you're going to be drawing a candy bar. I think of a rectangle. So start off by drawing your rectangle, showing your half, showing your 4/8, and show that it should be the same amount. I'll give you 30 seconds. All right, let's go ahead and check it. Let's look at your work. Here's a possible solution. The first candy bar, 1/2. The second candy bar would be 4/8. And to show it's the same amount, a picture like this. If you did that, say, good job. Let's look at one more problem together. Ryan and Wyatt each order a small pizza. They eat the same amount. Ryan eats 1/2 of his pizza. Wyatt's pizza is divided into 8 slices. How many slices of pizza did Wyatt eat? Draw a model to show your work. Again, draw a model. Show this work. 30 seconds. All right, let's start checking it. So, Ryan eats 1/2 of his pizza. I would have drawn a circle for the pizza, and I would have cut it into 1/2. Okay, 1/2. Wyatt's pizza is divided into 8 slices. Oh, let me see if I'm going to try to draw another circle of the same size. And I'm going to make it into 8 slices. So I'm going to do my half, my fourths, and then 2 more diagonal lines. And I'm going to shade in. And I hope you said 4 slices. 1, 2, 3, 4. One half is equivalent to 4/8. It's the same amount. Great work, students. Today we reviewed finding equivalent fractions. You sure did a great job. I will show you the independent practice problems now, or you can find them on the student practice for this lesson posted on our website. Students, I enjoyed working with you today on math. Thank you for inviting me into your home. I look forward to seeing you in our next lesson at Tennessee's At Home Learning Series for math. Bye-bye.
Hold on. You ready to have a snack? Yes?
More,
More? Okay.
more,
Let's count.
more,
1,
8,
2,
8,
3,
3,
4,
5,
and 5. Want to eat one? Up. Go ahead. How many did you just eat? Did you just eat one? Okay. Let's count again. We got 1, 2, 3, 4.
5,
4.
5.
You just ate the food.